From the dawn of humanity, the sun has held a place of reverence and fascination, a celestial marvel that has inspired myths, guided explorers, and marked the passage of time. It is a blazing sphere of plasma, a celestial giant that dictates the rhythm of our days and the seasons of our year, a cosmic clock that never stops ticking. More than just a beacon of light and warmth, the sun is the very lifeblood of our planet, a source of energy that powers the intricate web of life. It provides the energy that fuels photosynthesis, the miraculous process by which plants convert sunlight into the chemical energy that sustains nearly all life on Earth, from the tiniest algae to the tallest trees. Without the sun, our planet would be a barren, frozen wasteland, devoid of the rich diversity of life we see today, a desolate rock adrift in the cosmos. The sun's influence extends far beyond providing us with light and warmth. It is the engine that drives our climate and weather patterns. It shapes our climate, drives our weather patterns, and influences the delicate balance of Earth's atmosphere, creating the conditions necessary for life to thrive. Understanding the sun, its behavior, and its interactions with our planet is crucial to comprehending the complex systems that govern life as we know it, and to predicting the future of our ever-changing world. Deep within the sun's core, a process of unimaginable power unfolds: nuclear fusion. Under immense pressure and temperatures exceeding 15 million degrees Celsius, hydrogen atoms are forced together. This fusion process overcomes the natural repulsion between the positively charged protons in the hydrogen nuclei, causing them to merge and form helium. This fusion of hydrogen into helium is the engine that drives the sun's energy production. The process is remarkably efficient. A small amount of mass is converted into an enormous amount of energy, as described by Einstein's famous equation E = mc2. This energy, released in the form of high-energy photons, then begins its long journey from the sun's core to its surface. Once it reaches the surface, this energy radiates out into space, with a portion of it traveling to Earth, providing the light and warmth essential for life. The sun's energy reaches Earth in the form of electromagnetic radiation, a spectrum of energy that includes visible light, infrared radiation, and ultraviolet radiation. Each of these forms of radiation carries a different amount of energy and interacts with Earth's atmosphere and surface in unique ways. Visible light, the portion of the electromagnetic spectrum that our eyes can detect, is responsible for illuminating our world and allowing us to see the vibrant colors around us. It is also the primary source of energy for photosynthesis, the process by which plants convert sunlight into chemical energy, fueling the growth of nearly all life on Earth. Infrared radiation, which has longer wavelengths than visible light, is what we perceive as heat. It plays a crucial role in regulating Earth's temperature by warming the planet's surface and atmosphere, creating the conditions necessary for life. Ultraviolet radiation, with its shorter wavelengths and higher energy, is both beneficial and harmful to life on Earth. While it helps produce vitamin D in our skin, excessive exposure can lead to skin damage and other health issues. The sun's diverse radiation not only shapes our climate and weather patterns, but also sustains the delicate balance of life on our planet. The Earth is constantly bathed in the sun's energy, but it doesn't simply absorb all this energy. Instead, it engages in a delicate dance. This dance is a balance between the incoming solar radiation and the energy radiated back out into space by the Earth. Known as Earth's energy budget, this balance is crucial for maintaining a stable and habitable climate, ensuring life can thrive. When solar radiation reaches Earth, about 30% of it is reflected back into space by clouds, ice, and other reflective surfaces, acting like a natural shield. The remaining 70% is absorbed by the Earth's surface, atmosphere, and oceans, causing them to warm up and sustain life. This absorbed energy is then re-emitted as infrared radiation, some of which escapes back into space, continuing the cycle. The greenhouse effect plays a crucial role in this energy balance, trapping heat and keeping our planet warm enough to support life. The sun is not a static entity, but a dynamic and ever-changing star, constantly in motion and brimming with energy. It exhibits various cycles and fluctuations in its activity, some subtle and some dramatic, influencing the entire solar system. These solar rhythms, particularly the 11-year solar cycle, have a measurable impact on Earth's climate, affecting weather patterns and atmospheric conditions. The 11-year solar cycle is characterized by periodic increases and decreases in the number of sunspots, which are dark, cooler regions on the sun's surface associated with intense magnetic activity. During solar maximum, when sunspot activity is at its peak, the sun emits more energy, including increased ultraviolet radiation, which can have various effects on Earth. Conversely, during solar minimum, sunspot activity is minimal and the sun's energy output is slightly lower, leading to different climatic impacts. These variations in solar activity, though relatively small, can influence Earth's climate in significant ways over time. For example, during periods of high solar activity, the increased ultraviolet radiation can interact with the Earth's upper atmosphere, altering its chemistry and potentially influencing weather patterns, leading to observable changes in climate. By studying ice cores and ancient stone carvings, scientists have uncovered a rich history of how solar activity has influenced Earth's climate over millennia, providing valuable insights into our planet's past and future. While the sun's influence on Earth's climate is undeniable, it's crucial to recognize the profound impact humans are having on our planet's climate system. Our activities have become a significant force, altering the natural balance in ways we are only beginning to fully understand. Since the Industrial Revolution, human activities, particularly the burning of fossil fuels, have released massive amounts of greenhouse gases into the atmosphere. These emissions far exceed the natural fluctuations in solar activity, fundamentally changing the composition of our atmosphere. These greenhouse gas emissions have amplified the natural greenhouse effect, leading to a rapid increase in Earth's average temperature, a phenomenon known as global warming. The rate of this warming is unprecedented in the history of our planet, and its effects are far-reaching. The scientific consensus is clear. Human activities are the dominant cause of the observed warming since the mid-20th century. This conclusion is supported by extensive research and data analysis from scientists around the globe, leaving little room for doubt. The consequences of this human-induced climate change are already being felt around the world. From the poles to the equator, no region is untouched. The impacts are varied and profound. We are witnessing more frequent and intense heat waves, more severe droughts, rising sea levels, and the melting of polar ice caps at alarming rates. These changes are reshaping our world. Additionally, extreme weather events, such as hurricanes and wildfires, are becoming more common and more destructive. These events are not just natural disasters, they are exacerbated by our changing climate. These impacts pose significant risks to human societies and ecosystems, threatening our health, food security, water resources, and the delicate balance of life on Earth. The urgency to address these challenges has never been greater. We must act now to mitigate these effects and protect our planet for future generations. As we delve deeper into the mysteries of the sun, we gain not only a greater appreciation for its role in shaping our planet, but also a deeper understanding of the delicate balance that sustains life on Earth. The sun is not just a distant star, it is the very heartbeat of our world, influencing everything from weather patterns to the cycles of life. The sun's story is a reminder of our profound connection to the cosmos and the responsibility we hold in protecting our planet's future. It serves as a beacon, guiding us towards a deeper awareness of our place in the universe and the impact of our actions. Studying the sun is crucial for improving our understanding of climate change and making accurate climate predictions. By examining solar activity, scientists can develop models that predict future climate scenarios, helping us prepare for what lies ahead. By unraveling the complexities of solar cycles, we can better distinguish between natural climate variability and human-induced warming. This distinction is vital for crafting policies that address the root causes of climate change. This knowledge is essential for developing effective mitigation and adaptation strategies to address the challenges of a changing climate. It empowers us to take informed actions that can make a real difference. However, understanding the sun is not enough. Knowledge must be paired with action. We must act decisively to reduce our impact on the planet. This means making conscious choices in our daily lives and supporting policies that promote sustainability. Transitioning to a clean energy future, reducing greenhouse gas emissions, and adopting sustainable practices are essential steps in mitigating the effects of climate change and preserving a habitable planet for generations to come. Together, we can create a future where both humanity and nature thrive in harmony.